Okay, so here we have the three primary colors of light, red, blue, and green. And we know that all of the different colors in the visible light part of the spectrum have to fit within one of these colors of light because we only have three different colors of photoreceptors in our eyes. Red, green, and blue for the cones, and of course blacks, whites, and grays for the blocking of light. For contrast is going to be done with the rods, of course. Okay, so we have red, blue, and green light. This is as pure as we can get under these technological conditions. So let's ask, what do you think we're going to get if we mix the red and the blue light? Okay, let's make a hypothesis. What do you think we're going to get? You may be familiar with this color you're getting ready to see, and it may spark your memory and make you think of something that you've seen maybe at home or around your parents' office, something like that. Okay, well, let's go ahead and check. Now this is called magenta. Magenta is a deep reddish purple, and you will often see that in some paints as well as maybe your printing device. Okay, I thought so. So that is the mixing of red and blue. Okay, now let's move over here and let's see, what do you think we might get if we mix the green and the blue light? Okay, green and blue. Yeah, if you mix paint, you probably get about the same. Let's see. It's like kind of bluish green, kind of like the sea. Beautiful ocean. Maybe some of you get ready to go to for spring break. Okay, this is called cyan. Cyan is C-Y-A-N, and it's a pretty familiar color. Okay, kind of along with the magenta. Have you seen that? Printer as well? Okay. Well, let's do the one that we haven't seen yet. I'm going to go ahead and move this out of the way. We'll cover up the blue light here. Get something to block that. Okay, so now we have our red light and our green light. And if we mix them together, what do you think? Well, you're going to get a combination of maybe one of your old favorite childhood games, red light, green light, and make yellow light. I know it's kind of orange, maybe a little reddish, it just depends, but again, we're working with technology here, it's never perfect, but this is pretty clear, pretty much yellow in some areas, and we've noticed that if you move around the room, it actually looks a little different from different perspectives. Like here, I get a lot more yellow. But on the red side, maybe because I'm closer to the red light, maybe the photoreceptors in my eyes are picking up more red light than green. So it's balancing. And what's happening there, just like when we did the activity the other day, and perception, we have two eyes that are sending two different messages to our brain, so our brain is combining those messages. The same thing is happening with the light that's perceived from our photoreceptors. They're each sending an individual message, each of the thousands of photoreceptors, to our brain, and our brain is adding them together. And the additive property of light are these three secondary colors of light, or the primary pigment colors. Okay, well, let's actually put them all together. What do you think we will get if we take now the red light, the green light? Okay, what do you think we're going to get? Let's go ahead and add them together now. What do you think we might get if we add together the red light, the green light, and the blue light? Okay, well, let's see. We know red and blue make magenta. Leave that overlapping there. We have the green and the blue make cyan. We have the green and the red make yellow. And there we have a nice visual display of all of the colors. And again, in the middle, it's pretty much white. Again, we are over here. Looks very white from this perspective for me. But if I move over here, again, I'm receiving a whole lot of red light on this end. So let's see if we can move around and get some of that. Much different color from this perspective. I'm getting some more of the blues. We get a much deeper cyan. And then as we move this way, you can see how that white definitely changes to another color. Okay, and we'll go ahead and come back. Okay, so you can see here we have not only the three primary colors of light, which again represent the three different types of cone photoreceptors you have in the retina in the back of your eye. We have all of the secondary colors of light that we've achieved by mixing colors. We have, if I can find them, the blue and the green make cyan, primary pigment color or secondary color of light. We have red and blue light makes magenta. You can barely see that, it's down here. Okay, again, secondary color of light or primary pigment color. We of course have the red and the green, which makes a really nice yellow right here. It's bright from where I'm standing. But I love this effect. You can see I feel very psychedelic at the moment. Okay, and I have one other demonstration for you. I'll try it with the light on and see if this works. But here I have my light ball, which is supposed to represent somewhat of a white light. Of course, it wouldn't be that interesting if it were. We'll see if this works. And voila, red, green, and blue light. And together, they make white.